This is exercise 4.5, question 16. Now in the diagram, we are told that CD is equal to CE. So we know that now that this is an isosceles triangle. And we're also told that AB is equal to FE. And we're also told that GB, this line here, GB, or interval, bisects angle ABC. So before we start, we need to let, because we know some information in this triangle CDE, and we know some information about this angle ABC, and in particularly this angle here ABG, we should really label that angle ABG, and we'll just label one of the angles in this triangle, we'll label angle CDE. But they need to be labelled as different pronumerals because they're not equal in size. So we're going to let angle ABG equal alpha. So we'll just move that in on the diagram. And we're going to let angle CDE equal beta. Okay. Now, okay, let's work around this angle here, angle ABC. Again, we know that GB bisects angle ABC, so therefore angle ABG is equal to angle GBC, and they're both equal to alpha. So let's write that down. So we put that angle GBC, this one here, equals alpha because GB bisects angle ABC. So let's put an alpha in on our diagram again. So now we can actually see that the size of angle ABC equals 2 alpha because it's the alpha there plus the other alpha there. So angle ABC equals 2 alpha, sum of adjacent angles. Adjacent meaning angles that are next to each other. Okay, now we've got parallel lines here. AB is parallel to FE. We can use corresponding angles if we want and say angle FCD is 2 alpha, or we could go with angle FCB is 180 minus 2 alpha, but I'm just going to go with corresponding angles. So angle FCD equals angle ABC equals 2 alpha. Reason is that the corresponding angles and that AB is parallel to FE. So I'm going to mark in 2 alpha on the diagram. Now the solution that I'm writing up here is a bit different to the solution in the back of the textbook. The textbook does the co-interior angle, and it says that this angle in here is 180 minus 2 alpha. Now we've I think done everything we can right there. So let's work in this triangle here. If we know that we've got our angle at beta here, which is at D, we know that this angle down here at E would also be beta. So we'll just write that up. So angle CED equals beta. Reason, base angles of isosceles triangle, CD equals CE. Now you need to say that CD equals CE because the question never stated that triangle CDE is isosceles. Now, we'll just mark that beta in on the diagram as well. So what we can do here, we can say that angle BCE, this angle there, is also 2 beta because it's the exterior angle of triangle CDE. So just writing that up, angle BCE equals beta plus beta, which is 2 beta because it's the exterior angle of triangle CDE. And I'll just mark that in on the diagram as well. The only thing is that C is in the way, so I'll just put that 2 beta down there, but it should be where the C is. Now we can see that this 2 alpha equals 2 beta because they're vertically opposite angles. But we'll just formalize this and we'll say that angle FCD is equal to angle BCE because they're vertically opposite angles. So I'll just write that in now. So angle FCD equals angle BCE, vertically opposite angles. Now just putting in what their values are, therefore we can say that 2 alpha equals 2 beta, and then just dividing both sides by 2, we can say that alpha equals beta. Now, because alpha equals beta, then this alpha here, so angle GBC, is equal to this beta down here, which is angle CDE. Now, remember, we're trying to prove that GB is parallel to DE, and the only way we can do that is by showing that, say, alternate angles are equal, or co-interior angles are supplementary, or that corresponding angles are equal. Now, the only angles that we can see between the lines GB and DE are the alternate angles. So angle GBD, that angle in there, if we do our backward Z, we're just running along there. So because we know that alpha equals beta, then therefore GB must equal DE, because those two angles, those alternate angles, are equal. So we're just going to write that up now. So angle GBC equals angle CDE. And we can also say that, well, their positions are that they are alternate angles. So those two angles, GBC and angle CDE, are alternate as well, and they're also equal. So therefore, the conclusion is that GB is parallel to DE because alternate angles are equal. And that's the end of this question.